All right, today we're going to work on the line of best fit. This is section 4.4, and we're going to focus on the end of our purpose, which was the purpose for this standard was to interpret the parameters of a linear function in terms of the context. So we're going to take this piece of data that discusses sales of DVDs and through time periods, through weeks. So the table shows the weekly sales of DVD and the number of weeks since its release. Write an equation that models the DVD sales as a function of the number of weeks since its release. Interpret the slope and the y-intercept of the line of fit. Okay? So the first thing we're going to do, everybody's going to be, you'll need a straight edge, so please make sure you pull out a straight edge and do not use my calculators. Okay, we're going to pause the recording, get yourself a straight edge. You should have graph paper. If there's anybody that doesn't have graph paper, you can come up and get one. Okay, guys, so now first thing we're going to do is graph this. In order to write a line of best fit, we have to create the graph. So here we go. We're going to write, that means we're going to need an x and a y-axis. What numbers need to be covered on the y-axis? What numbers need to be covered on the y-axis?
5 to 20.
5 to 20. And what numbers need to be covered on the x-axis, Aton? 1 through 8. So on my x-axis, hold on, I'm going to switch my graph paper to, where's my other graph paper? Small. There we go. Okay. So I'm going to make this. Okay, let's go. So it's going. No, I don't like that. Okay, I'm making every line worth 1 on the x-axis. So I'm doing 2, 4, 6, 8. You guys with me? And on the y-axis, let's see. 2, 4, 6, 10. Let's see, 2. 16. I'm going to raise this up a little bit. I got enough to actually do this. So I'm going 2, 4, 6, 8, 10, 12, 14, 16, 18, and then I have 19 is right up there. Okay? And what else do I need for my graph? My graph makes no sense right now. If I were to open this up and look at it in the newspaper, what does it represent? Yes.
The x-axis and y-axis.
I need to label x and y, but what else do I need? Yes, Mike?
You need to write like the week and like
Where does weeks go?
the weeks go on the x-axis.
Right, this is our x, weeks. And where does our y go?
On the y-axis.
I mean, what am I putting for the y-axis?
You put sales and then you put
Sales of what, guys?
millions.
Of DVDs. Because that's what it's talking about. In millions of dollars. These are dollars. All right, and then we start to plot our data. So I want you to go through and plot your data. Okay, so I'm going 1 to 19. And then I have 2 to 15. And then I have 3 to 13. And then I have 4 is 11. And then 5 is 10. And 6 is 8. And 7 is 7. And then we have 8 is 5. So it's not exactly a straight line, right? Now, when we draw our line of best fit, remember we create a line that's like, imagine it's a piece of metal and actually it's a magnet. Imagine our line is a magnet, or our line is a piece of metal and these little dots are a magnet. So we want to place that line where we'll attract most of the dots. We really kind of want our line to go through. And does it have to go through every dot? No. So I'm going to, so just draw your line. My line's going to be different than your line. We're all just drawing the line, okay? I'd really like it to go a little bit lower. But I just drew mine like that. It's hard on the iPad. Okay. So now I have to choose my points, and you need to choose 2 points on this. And what can we do with 2 points? We're going to find a slope. Now you can choose points that are on the line, or you can choose points that are not on the line. So I'm going to choose, okay, you guys choose your points. Go. Pick your 2 points. Okay. I'm choosing 8, 4. Okay, I know it's probably different than what you have. And I'm going to choose, that's 2, 15. You guys with me? Now, I bet people chose different numbers, right? What points did you choose? What did you choose?
3, 13, and 12, 1.
3, 13, 3, 13, 3, and 13. Okay. And what else? And what one?
I did 12, 1.
12, 1. Okay, so then he's going over here. 8, 10, 12. 1 here. Okay. Yep.
I did 8, 5, and 3, 15.
And 3, 15.
Everyone has different lines, so it depends on which line you're using.
Yeah, it depends on how you graphed it and how you saw it. So, okay. What did you get?
I did I did 0.22 and 6.8 and 6.8.
0.22.
I don't know. I think I did it wrong.
Okay. So you really kind of want to like at least try and stay within this range. It's so far out. Now I told you don't pick them too close together, but you're going so far out. I would definitely try and stay within this range. All right, so now what's the first thing we can do? We can find our slope. So I'm going to do, what do we do to find our slope? What's the formula? Yep.
M equals y2 minus y1 over x2 minus x1.
And so I'm subtracting whatever, your y's. You find your slope right now for yours. 15 minus 4.
I did 3/15.
Okay, so I'm doing 15 minus 4. Oh, 2 minus, okay, I got it. Okay, and when you get that fraction, I want you to convert that to a decimal. Okay, what decimal would that be? You've got a calculator, so divide it. Okay, so now I'm ready. I've got my slope. And now I need, what else do I need in order to do this?
A point.
A point. So I'm just going to take that 215, either one of your 2 points, and I'm going to use my point slope because I'm favorite to that. I like it better. Y minus y1 equals x times, m times
The quantity of
x minus x1, and now I'm substituting in y minus, this is x1, y1, so I'm doing y minus 15 equals -1 and 83/100 times x minus 2. And now I've got to simplify it. You've got a calculator. Y minus 15 equals -1 and 83/100 x minus, now 1.83 times 2 is 3.
What do you do with the repeated sign on the top?
It doesn't, we're just going to estimate it to 3. So plus 3.66. When I distribute it, negative times negative should make a positive. And then we're doing plus 15, y. And by now, we should be using, because once we put in our regular data, our real data, we're using the about sign. Does everybody understand that? I really should have been using it the whole way through. Y is about equal to negative 1.83 plus 18.66. Okay, how did yours work out?
Pretty well.
How did yours work out? How close is it to mine?
Pretty close. It's
Gracie, what is yours?
y is approximately -2x plus 21.
-2x. Oops, I left out my x. She got, okay, so these are the different ones we got. And I'm going to put them in blue over here. Y is about to -2x. Keep going.
Plus 21.
Plus 21. What else? Yep.
Mine is y is about -2.3x plus 22.
Is about -2.3x plus 22. Okay. What else? Yep.
Y is about -1.5x plus 17.
Okay. And this is mine. So, you're pretty, who did 2.3? You're pretty far off. But loosely around it. If I were using this for prediction purposes, it's within the range. The y-intercept's within the range. The slope is within the range. It's, literally it's 5/100 off, 5/10 off. So it's a half off. But it's within range. Do you guys understand that? There's no way that my equation, if we're doing this at home, is going to come out the same as Elise's when she's at home. Because she's going to draw hers different than the way that Gracie draws hers. And you might take different points. Now, let's talk about the points that I took. Look at my points. Do they come from the data set?
Yeah. Oh, wait, no.
No. So most of you guys chose like 313 and what else?
7.
Some people chose 7.7. Some people chose 8.5. But I chose one of my data points is on here. The 215 that I chose, that's on there. But my other one is close to this, but it's not this. So do you understand when you choose your data points, you don't have to use the real data. I could use something on the line. I chose it because I don't know. It looked, on my other graph, it looked closer to the edge of a box. That's why I chose it. Okay? But this is my line of best fit. These are your lines of best fit. They should be within the same range. If you're getting plus 55, then you're not even close. You're doing something wrong mathematically. If you're getting minus 300, you did something wrong. Do you understand? But for the most part, we're all within the same range. Does that make sense? All right, so we've got our line of best fit. The next thing we need to do is interpret our slope. Okay, so I'm going to go on to the next page. And remember, whoops, I'm going to skip 2 pages. So remember when we had this represents DVD sales. And then this represents weeks. Right? And so can you guys read me what the equation was? Y is about equal to what?
Negative 2x plus 21.
No, mine was -1 and 83x plus 18 and 66. Okay, so first of all, to analyze the slope. Okay? To analyze the slope, I want you to put it over 1. Okay, so when we are analyzing, remember the protocol is we always identify first. So we would say what? The slope. Huh? What am I saying? The slope is -1 and 83 hundredths. Now, what does that mean? We have to relate it to your y, your change in your y, over your change in your x. What does the y really represent? Guys, what does your y represent?
Y is DVD sales.
DVD sales. Over, what does the 1 represent? The x? Weeks. Okay, so tell me what that means. Now that we've tied our change in our y over our change in our x, what does this mean?
Everyone.
In a words, go, Noah.
Every week there are negative 1.83 million sales.
Nope, close. You're very close. Go, Max.
Every week the DVD sales go down 1.83 million.
Yeah. Each week, so this means, so again, the protocol is the slope is, this means. Each week, there is a drop of $1.83 million of sales. All right, so I did the protocol. I said the slope is, I said this means, and I explained it. Does this make sense? Okay, so we can stop there. We don't need any commentary. Now let's do our y-axis. Our y-axis. Let's go back. Our y-intercept. What is my y-intercept?
18.66.
Give me an ordered pair.
Oh, 0, 18.66.
What does that mean? Oops. Now let's go back to Okay, so again, same protocol. The y-intercept, you should be writing what I'm writing, not steering. What do I write, guys? The y-intercept.
Intercept is 0, 18.66.
Right, 0, 18.66.
This,
What do I say?
This means that
That's today.
This?
0 weeks from now, that means that now the DVD sales have gone down 18.66 million.
Damn. Isn't it just their ad?
No. Wait, yes.
Okay, what does that mean, the 0? Yes. Okay, this means we started off with $18.66 million in sales. Okay, let's go to the y-intercept. The x-intercept. Okay? Does this make sense? Yeah, kinda. It means when we started looking at the point in time that we started this graph, there was about $18,066,000. And so we tried to create a graph to show us is DVD sales rising or is it dropping? Why might it be dropping?
People aren't buying it.
Why?
You can just download music for free.
Yeah, it's like it's becoming, it's probably one of the first things that's going to disappear out of your generation that will no longer become a necessity. Why carry these big, cumbersome things and you have stacks of them when you can just download? Everything is streamed now. When they try to give me DVDs when I go to these camps, I'm like, can you just send me the link and I'll just email it? I don't want to have storage for that. So it's becoming obsolete, those DVDs, and it's clear in the graph. Yes.
The last Blockbuster closed.
Yeah.
Yep, recently.
That was like
All right, let's keep going. We're recording. So now let's go to our x-intercept because it asked us to, I believe it said, can we continue? Interpret the slope and the y-intercept of the line. I want to kind of go to this x-intercept. What is it looking like that would be?
In 12 weeks, they won't be making any money selling CDs.
Right. Perfect. So our x-intercept, if we looked at that right here, in 12 weeks, we are likely to not be making enough money to pay for them, right? The sales will drop so much, we won't be making. Is it necessarily going to happen? Do you think that's a realistic situation?
No.
Now, you could say in your x-intercept, when you're talking about it, you could say, so we said the x-intercept, we used approximately, what was it, in 12,
12 weeks.
comma 0? Okay, so how would it be written? What's the protocol?
In 12, the x-intercept is 0, 12, which means in 12 weeks they won't make any money selling CDs anymore.
The x-intercept is, and again, this is what your quiz is on, so I'd be writing 12, comma 0. This means in 12 weeks, there will be 0 money made on DVD sales. If we continue the pattern. Now, the last thing that you're going to write, because sometimes your x and y intercept are not going to make sense. So if it doesn't make sense, you're going to say, this does not necessarily make sense in the context of the problem. you writing? You all look like you're sitting. This is what I'm expecting tomorrow. If you're not doing it now, you definitely won't have it. So this does not necessarily make sense in the context of the problem. Why?
Well, because people are still going to buy CDs.
Because
DVDs. Like I still.
DVDs will not completely disappear in exactly 12
Yeah,
weeks.
like, I still.
And then you're going to write because DVDs will not just disappear in 12 weeks. All right, so now we have interpreted the slope. We found our line of best fit. We've interpreted our slope. We've interpreted our y-intercept, and we've interpreted the x-intercept. Yes?
I don't understand how we got 12 for this.
We looked at the diagram that we found. We just estimated it. It really should be like, because if this is 6, 8, 10, yeah, it really should have been like if this is 8, 9, 10, 11. It's really like 11. Do you see? I just chose where this line, that red line, finishes. That's the x-intercept. So it's 0, 11. She's on hers. We used hers, and it looked like 12. Does that make sense? All right. So are you clear on how to interpret slope, y-intercept, and x-intercept?
Yes.
Okay. So now let's put this in the graphing calculator and see how close we get. Okay. I'm going to turn this off. Write down my equation. Compare it to yours and compare it to the one in the calculator. Okay, did everybody write down my equation? Because I'm going to erase this right now. Y is about equal to negative 1.83x plus 18 and 66 hundredths. Okay?
Hold on.
Okay, using the calculator. So everybody's calculators should be cleared. Now, I don't have the data, so can somebody, let's see. Well, I'll just read it out, okay? So you guys are going to read it out to me. So the first thing you're going to do is clear it. Second plus 712. Okay? Now, the first thing we're going to do is we're going to put our data into a table. Everybody's going to hit stat. Okay? Hit stat. Now, we are going to hit, it's already on edit, so we're going to hit enter. Now, notice, this gives me multiple tables so that I can put on multiple stat plots, right? I don't have to erase it. So who can read me the first line of the data? I think it went 1 to 8, right? Right? So you're substituting in. Do you not have a calculator? Okay. So you're going to put in 1, and then you're going to arrow down or hit enter. 2, arrow down. 3, arrow down. 4, arrow down. 5, arrow down. 6, arrow down. We went to 8, right? 7, arrow down. 8, arrow down. Is everybody done with that? Now we're going to arrow over to the right, and it will take us to the top. And we are going to hit, what went with 1 in the data? You guys have the table.
19.
So we're going to type in 19, and then we're going to arrow down. And what's the next one? 2 goes with 15. 3 goes with 13. What's next?
11.
11. Next.
10.
Okay, next.
8.
Next.
7.
Next.
5.
What, 5?
Yeah.
Okay, we've got our data in there. Huh? Okay, you guys ready? You want to take a look at it? Okay, so when I go to graph, there's nothing there, right? We have to because it's really kind of thinking from the y equals. So we're not using that. We're using our statistics plot. So do you see where it says stat plot on top of the y equals? Is blue. You're going to hit second, and we're going to hit y equals to turn on the stat plot. Now you'll see plot number 1 is off. You with me?
Yes.
So I am going to arrow to the right, or I'm going to hit enter, and it kind of like, if I hit enter, it takes me here. Now do you see how on is blinking? I'm going to hit enter again. Now it moves it all over and turns it on. You guys with me? Okay, now I want it to be a stat plot. These are different kinds of graphs you can create on here. I want it to use list 1 and list 2 because that's where I entered my data. And I can choose to, I'm going to arrow down, arrow down, arrow down. I can change list 3, list 4, whatever. I can change it to be a box or a plus or a little big dot or a little dot. I think I'm going to change it to be just keep it as the box, but I'm going to make it be a different color. So I'm going to arrow down to the color, and I'm choosing magenta. And then I'm hitting enter, and then I'm going to go back to, now, I've turned on my stat plot. Do you see that, guys? I'm going to go to graph. Now we're close, but what's the problem?
You can't see all of it.
Right, so we need to change the window that we're looking at. So now you're going to hit window. Now, see where it says X min? That means what's the minimum you want to see on the x-axis?
Zero.
Negative 0?
No, just zero.
Just 0. We only used the first quadrant. So the minimum we want it to be is 0. The maximum on the x-axis, 10 is good. And I want it to increase by, the x scale is how much it's increasing by. I'm going to say by 1. The y minimum, what do we want the y minimum to be? I want it to be 0 again. But the maximum has to go to, let's say, 20. All right, let's just go positive 20. And do we want to make the y scale by 1? Sure, why not? I can do it by 2. I can do it by 5s. I think by 1. The smaller it is, the more of the data you see. Now, we can hit graph, and we can see our data. So there's the scatter plot. Now, oh, I know how. Okay, so the next thing we're going to do is we're going to go, and we're actually going to calculate our line of best fit and compare it to the one we got. So I'm going back to stat. Everybody goes to stat. And then I'm going to go to calculate. I'm going to arrow over to the right. And we're going to go down to number 4. See where it says linreg? That stands for linear regression. And that is what we're doing. A line of best fit is the fancy name is linear regression in math terms. It's a linear regression. So I'm going to arrow down to it. And we're hitting enter. And I'm telling it I want it to use my data from list 1 and list 2. And then we're going to arrow down all the way to calculate. And now look what they're giving us. They're giving us the equation in terms of y equals ax plus b, where the a is like our m, right? So y is about equal to negative 1 and 83/100 x plus 19.25. Now, what was my original equation? Y is about equal to negative 1 and 83/100 x.
Plus 18 and 66.
Mine was pretty close. And I got that the first time in first period, not knowing anything. Those were the numbers. And what does it come from? It comes from my experience of being able to choose points on that line and really looking at it. But it doesn't mean that your equation is not right. You have to be within the same range. So tonight you're doing it by hand because you don't have the graphing calculators. Yes?
Do you have to use graphic calculators on the test?
No, just like, on the test, I probably will allow it. You don't have to. You don't have to. You can do it by hand. But tomorrow you're really you're graphing. I'm not doing line of best fit on it. I'm doing interpreting your slope, your y-intercept, make an input-output table.
Are there like certain
Okay, can I finish the recording? Thank you. Okay, so is everybody clear on this? How close is what we got to what you had? In the ballpark? Very warm?
Yeah.
Yeah. Now, if I want to, so it's plus 1925, right? I believe if I want to get that line of best fit in there actually on the graph, I think I go here. Hold on, let's see. I think if I go to y equals now, and what are we putting? Negative. Oh, I better put this negative. Negative 1 and 83 hundredths x. Oops. Negative 1 and 83 hundredths, and then I'm going to this x is right here. Do you see that? And then I'm doing plus, it was 1925?
Yeah.
19. And then if I go to the graph, look at it. There's my line of best fit. I've got the points, the true data points. Is that clear? All right, so tonight you're doing them by hand. They should be small enough, the data sets. There's about 4 of them, and you're trying to create the line of best fit. Now, her answer is going to be different than her answer. It's going to be different than her answer. If you look at the odds, they have the answer there, and that should tell you if you're at least, our goal is to at least get you in the ballpark. Does that make sense? If you were a mathematician, you wouldn't be doing it by hand. You'd really be using a graphing calculator. Okay, let's go back to our one problem. Are there any questions here? There's one more. We have a couple more minutes, so I may as well do this. There's something called a correlation coefficient. And a correlation coefficient, I'll go back and explain it again tomorrow. Correlation, everybody say that. Coefficient. Okay, our correlation coefficient is a measurement that goes from -1 to +1, where this is a strong measurement and this is a strong measurement, but this is weak. Okay, now, is this a positive or a negative slope? Negative. So really, when I'm looking at the correlation coefficient, it should come out negative. Now, I'm going to show you how to do it. It'll take just another minute. Correlation coefficient. So if it's close to +1 or -1, it's very strong, and if it's close to 0, it's weak. So let's go to, the first thing you need to do is go to mode. Everybody go to mode. Did you see that? Now you're going to arrow down to something called stat diagnostics and turn it on. Arrow down to stat diagnostics, not stat wizards. And you're going to arrow over to on, and then you're going to hit enter. Okay? Now we're going to go back to stat. You ready? And now I'm going to arrow over to calc, then down to number 4, and we're going to hit enter, 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 enter. Now, what is my R that they come up with? So here's my equation. Y is about equal to -1 and 83 hundredths x plus 19 and 25 hundredths. And my R is equal to what? Is about equal to -0 and 98 hundredths. Would you say that's strong or is it weak?
That's strong.
Strong. Now what that means, the correlation coefficient, it tells you how good of a line of best fit this is. So if I were using this to predict future data, like sales this is a likely equation that I would use because it has a strong correlation coefficient. Does that make sense? The closer it is to -1 or +1. Now it's negative because the data is decreasing. It is 0.98. It means that the data is makes a good line of best fit. Now, when is it not going to be a good line of best fit? What?
When it's 0.
When it's 0. But in the graph, maybe my data is really spread out. Maybe my line is really skewed. Could be a couple of different things. Does that make sense? Okay, we will talk more about correlation coefficient tomorrow. This is a long video, and that's it for today. Line of best fit, 4.4. You are doing 15 through 24. You don't have a graphing calculator, so you'll be calculating those line of best fit on your own. Find the slope, find the y-intercept,